Alright, this lesson is on scientific notation, part number 1. The first part that I'm going to show you is basically how to recognize scientific notation and then also recognize what proper scientific notation looks like. So I'm going to use the first several examples that I have up here just to help you recognize scientific notation and recognize what proper scientific notation looks like. Then down below, we're going to go ahead and take a look at roughly 8 examples. And we're going to convert from decimal notation to scientific notation. So I've got 4 examples here, and then I've got 4 examples here, and then we'll be done. So let's start back up here. These first set of examples are numbers that are all written in scientific notation. Every one of them are in scientific notation. I'm not saying that they're written in proper scientific notation, but they are all in scientific notation. Scientific notation basically looks like this. You have a number that sits out in front, followed by a multiplication sign, followed by the number 10, and then some exponent. So the thing that's always the same is the times and the 10 and the exponent. Times 10 and the exponent, times 10 and the exponent. The exponent will change and the number out in front will change as well. Real quick commercial. Scientific notation is used to rewrite either really big numbers or really small numbers in a way that is a little bit more concise, a little bit easier to write down. Some numbers in science can get so big or so small that when you put them on a piece of paper, it just is easier to it's easier to write the number in a compacted form, like scientific notation, as to write the number out in its really long form. So let's take a look at these. Proper scientific notation means that the number that sits out in front has to be, I'll write this over here, has to be, I'll put it right here, I guess. It has to be greater than or equal to 1. So that's not a real good way of saying it. The number out in front has to be bigger than or equal to 1. Okay, so it has to be bigger than 1. It can be equal to 1, but it has to be either equal to 1 or bigger than 1. And it has to be smaller than 10. Kind of a fancy way of showing that would look like this. That's a fancy way of showing it. And we really haven't talked about that type of notation yet. But x has to be smaller than 10, yet bigger than or equal to 1. So we're going to basically just go down this list of numbers that I have written here, and we're looking for numbers that are out in front that are either bigger than, so we want to make sure that the number that sits here is either smaller than 10 or greater than or equal to 1. That's what we're looking for. If it's not smaller than 10 or greater than or equal to 1, we're going to basically take note of that. So let's look at what we've got here. 3.4. 3.4 is between 1 and 10. So this one's okay. This would be improper scientific notation. That word there is okay. The next one, 3.4. Again, perfectly fine. It's between 1 and 10, and it is improper scientific notation. The exponent really doesn't matter. As long as it's an integer, it's perfectly fine. Let's look at this number here, 1.267. 1.267, that's bigger than 1. So that's perfectly fine as well. Here's the next one, 0.5. That number is less than 1. It doesn't mean that it's not in scientific notation. It's just not in proper scientific notation. So this number here is not in proper scientific notation. The next one, 16. 16 is bigger than 10, so it's not in proper scientific notation. Here's the next one, 2,502.2. It's not. That number is obviously greater than 10, so it is not in scientific notation. Here's the next one, 0.00027 times 10 to the negative fourth. That's obviously smaller than 1, so it's not in scientific notation. How about over here? I'll write 4 or 5 numbers down that are written in scientific notation. You use your neighbor. You don't have to rewrite them, but just identify the ones that are in proper scientific notation and the ones that are in that are maybe not in proper scientific notation. So here you go. Let's start with 0.26 times 10 to the fifth. There's the first one. Maybe I'll zoom in a little bit. There's the first one. Let's go to the next one. 1 times 10 to the negative sixth. We'll do 4. Let's see, 6.27 times 10 to the fifth. And the last one, let's go with 2,265,167.5 times 10 to the negative fourth. All right, why don't you, with your neighbor or someone, and think through which one is improper scientific notation, or which ones. There might be 2. Okay, hopefully you've had enough time. Let's go through them real quick. This number here, that's smaller than 1, so this is not improper scientific notation. 1, okay, 1 is okay, because it can be equal to 1. It can be equal to 1, that's perfectly fine. So this one is okay. Let's go look at this one, 6.27. That's smaller than 10, but then greater than or equal to 1. So that one's okay as well. This 2 million one, there's no way. So that's not in scientific notation. Let me throw one more at you while I'm thinking about it. How about 1.26 times 10 to the fifth? Is that one improper scientific notation? And the answer is yes. It is, because this number here is less than 10 and greater than or equal to 1. So this number is still bigger than 1, and so this one is in, I don't want to circle it, this one is improper scientific notation, so that's all good. Okay, let's go down to the examples down that we have below. Now that we know what proper scientific notation looks like, let's just take a little bit of time and work on converting a number like this one to scientific notation. So when I look at this number, I first need to find its decimal. And the rule of thumb goes like this. If a number doesn't have a decimal, its decimal then is understood to be out on the far right hand side. And so I'll just go and put a decimal there just so you can see it, and I'll do it in red. Now we have to decide where to put the new decimal, because we're going to move it. We could move it to a point over here, to a point here, here, or here. We have a lot of decisions to make. Let's say that we put it right here. That number then would be 265. Well, remember when we do scientific notation, we want that number to be smaller than 10. And 265 is greater than 10, so that's not going to work. Let's do another one. What if I put the decimal point right here between the 5 and the 6? Well, that wouldn't work either, because 25.67 is still bigger than 10. How about if I put it right here? If I put it right here, that number is 2.567. That number is bigger than, let's see, it's smaller than 10, but greater than or equal to 1. And so that would work. So we're going to put our new decimal right here. Do it in blue. So then all we have to do now is count over how many humps. So let's see here. It was here. I'll go 1, 2, 3. I move 3 spots. If I move 3 spots, this 3 becomes my new exponent. So this new number is going to be 2.567 times 10 to the positive 3. And there it is. Let's do another one. Let's look at this one. Let me zoom in just a little bit. We have 176 million. Again, if we don't know where the decimal is automatically understood to be out on the far right-hand side. Next step is to find where we want to place our new decimal point. In this case, we don't want to put it anywhere here, because that's going to give us a number that will give us a number that's bigger than 10. But if I put it right here, 1.67, Ignore all the rest of the zeros. 1.67 will make a number that's smaller than 10, but yet greater than or equal to 1. And so let's see, how many times do I have to move it? So it was here. 1, 2, 3, 4, 5, 6, 7, 8. I moved it 8 times. That'll be my new exponent. So it's 1.76, we don't need the rest of the zeros, times 10 to the 8th. And there it is. Let's go over here. Let's look at this one. I'm going to look at E and F. If I look at E and F, the decimal sits over here. Notice that this number is actually smaller than 1, and these numbers were bigger than 1. Big difference. So the question is where do I put my new decimal? I already know where it is. Where do I put the new one? Well, if I put it right here, then that number becomes 125. I need a number that's smaller than 10. If I put it right here, that becomes 12.5. That's still too big. If I put it right here, then bam, that one is going to be between 1 and 10 and still, less than 10. I keep saying that wrong. It'll still be less than 10, but greater than or equal to 1. All right, so how many places will I move it? Well, it was here. 1, 2. I moved it 2 places. Now notice, which way did I move it? I moved it to the right. If I moved it to the right, then my exponent is going to be negative. Look at these over here that I just did. Where was it at? Here it is. It was at the red, now it's at the blue. I moved to the left. If I move to the left, it's positive. Look at this one. Moved it to the left. It's positive. If I move it to the right, then I want to make that number that I move negative. So my new answer is going to be 1.25 times 10 to the minus 2. Let's do the next one. Here's where the decimal point is. If I move it to here, that's smaller than 1. If I move it to here, it's still smaller than 1. Smaller than 1, smaller than 1. If I move it here, then that becomes 2.8. That 2.8 is smaller than 10, but bigger than or equal to 1. And so that works out just fine. So here it is. So it'd be 2.8 times 10. And how many times? 1, 2, 3, 4, 5. Since I moved to the left, it'll be negative 5. All right, I have 4 examples. I'd like you to take all 4 of these examples and work with your neighbor or someone close to you and convert each of those to scientific notation. Let me erase this. So this is 256.625. This is 8,756,253. This is 0.015, and this is 0.2730053. I'll give you a few minutes, and let's see what you can come up with. Okay, let's see what you came up with. Here's the first one. Let's see, our new decimal is going to have to go right here. 2.56625 is smaller than 10 and still bigger than or equal to 1. So how many places do I have to move it? 1, 2. So it's going to be 2.56625 times 10. See, that was 2, so I moved it to the left. Times 10 to the positive 2. And there it is. Let's do letter D. Letter D, the decimal is not given, so we understand it to be on the far right-hand side. The new decimal is going to have to go right here. So that becomes 8.756253, which is, let's see, bigger than or equal to 1, but still less than 10. So that becomes 8.756253. Move it once, twice, 3, 4, 5, 6. Did I do that right? 1, 2, 3, 4, 5, 6. 6 times, and so that'll be times 10 to the 6th. And there it is. 2 more. I'll have to put the decimal point between the 1 and 5 so that 1.5 is bigger than or equal to 1 and still less than 10. I move it twice, and remember I moved it to the right, so that'll be a negative 2 on my exponent. So 1.5 times 10 to the minus 2. And the last one, I want to go right, it is right here, and I'll put it right here. So I'm going to move it once. So that'll be a negative 1. So 2.730053 times 10 to the negative first. And there is scientific notation. Good luck on your homework.